Today we will be constructing an electromagnet. Project number 1 of Dowling Magnet's Science Discovery Electromagnet Kit. To construct, you will need 2 battery holders, a compass, a light bulb with leads, magnetic wire, masking tape, 1 16D finishing nail, 2 4D finishing nails, a sheet of fine sandpaper, 1 small pre-bent piece of sheet metal, a 2.5-inch plastic drinking straw, 1 wooden block, 4 D-cell batteries, 2 small wood screws, a pen, a wire coat hanger, wire cutters, and 2 pieces of corrugated cardboard. First thing we need to do is create a winding mechanism. Take the corrugated cardboard and fold it into quarters. Use the box the kit came in as a base for the winding mechanism. Tape the folded cardboard onto the side of the box. Take the coat hanger and cut it into a 7-inch piece and a 10.5-inch piece. Bend the 10.5-inch piece into a crank. Push the wire hanger pieces through the peaks of the corrugated cardboard and the box. Now, take the large nail and place it into the plastic straw. This will add stability to the straw while winding. Place the nail and straw between the wire hanger pieces and tape them to each end. Using a coffee cup as a base, take the pen and put it through the spool of magnetic wire. Pull several inches of wire to use as a lead and tape it to the plastic straw. Begin slowly winding the magnetic wire around the straw. You can experiment by just winding a few loops of wire around the straw to see how strong the electromagnet is, and then increasing the number of loops to see a change in power. For our purposes today, we will be winding several hundred loops layered over each other for maximum power. Take your time with this step to make sure your windings are tight. Make sure to end your winding at the opposite end of the straw from where you started, and cut the wire leaving several inches for a lead. Use the sandpaper to sand off the insulation from the ends of the magnetic wire. Try to get it as bare as possible for better electric connectivity. Now take the wooden block and place a small screw into the corner hole shown. Before screwing the screw all the way in, hook the negative lead from the battery pack around the screw. Now screw the lead into place. Now take the bent piece of sheet metal and screw it onto the block as shown. The end of the sheet metal should be over the first screw. Before screwing the sheet metal all the way in, loop a lead from the magnetic coil around the screw. Screw the sheet metal down all the way, securing the lead into place. Now, connect the loose positive and negative leads from the battery packs together. Now connect the last positive lead from the battery pack to the open lead on the magnetic coil. Put the batteries into the battery packs. To test and see if the connections are good and the electromagnet works, place a compass next to the magnetic coil. Now press down on the sheet metal and touch the screw beneath it to complete the circuit. Did you see the compass move? To make this more visible, let's add a light. Cut the lead connecting the magnetic coil to the sheet metal, leaving several inches on both sides. Make sure to sand the insulation off the new ends. Place the new leads into the two holes at the opposite corner of the wooden block. Take the light bulb and place each lead into the holes. Now, place two small nails into the holes to secure the connections. Press the sheet metal down to complete the connection and see if the light comes on. Going further, try experimenting with less batteries, a smaller magnetic coil, or more lights. Have fun! The Science Discovery Kits will celebrate their 20th anniversary in 2013. Dowling Magnets would like to thank the inventor and creator, Dean Knight of Sonoma Valley High School in Sonoma, California, for all his work on these top-selling science kits. Follow us on Twitter at Dowling Magnets. Like us on Facebook.com/DowlingMagnets. And for more product information, please visit dowlingmagnets.com.